In this example, we will evaluate the definite integral from 1 to 2 of the square root of x squared minus 1 over x. Now the immediate observation to make here is seeing this expression x squared minus 1 underneath the square root is really a key indicator that we should try trigonometric substitution. Because it's of the form x squared minus a squared with a equals 1, we're going to use the substitution x equals secant of theta, so that dx is equal to secant theta tangent theta. Also keep in mind, because it is a definite integral, we have to switch around our limits of integration. So if we think about that lower limit of integration, when x is 1, that tells us that 1 is equal to secant of theta, which means that theta is equal to 0. If we look at our upper limit of integration, x is equal to 2, that means 2 is equal to secant of theta, which means cosine of theta is 1/2, so theta is pi over 3. So expressing our integral now solely in terms of the variable theta, we have the integral going from the lower limit of integration 0 to the upper limit of integration pi over 3. The integrand, each x needs to be replaced with a secant. So the square root of secant squared theta minus 1 divided by secant theta, and the dx becomes secant tangent d theta. And now that we've converted into this trigonometric integral, we want to immediately kind of rewrite via the corresponding identity. So remember that secant squared minus 1 is tangent squared. And then doing a bit of simplification here, secant over secant cancels, and we have a tangent theta d theta remaining. So this gives us the definite integral from 0 to pi over 3. Square root of tangent squared is tangent, times another tangent is tangent squared. So once we have applied this trigonometric substitution, the integral that we started off with is reduced down to evaluating, in this case, an equivalent trigonometric integral. And thinking about the guidelines we have for evaluating integrals of this form, because it's an even power of tangent, no secant term present, we rewrite that tangent squared in terms of its Pythagorean identity. So this would be the definite integral from 0 to pi over 3 of secant squared theta minus 1. And now we just anti-differentiate each term individually. So tangent minus theta. And we evaluate from 0 to pi over 3. So we first plug in a pi over 3. So tangent pi over 3 minus pi over 3. Then we put a minus sign and we plug in 0. So tangent 0 minus 0. Well, recall tangent of 0 is equal to 0. Pi over 3 is a common value for tangent. So that would be sine pi over 3 over cosine pi over 3. So root 3 over 2 divided by 1/2 is root 3. So we end up with the solution being square root 3 minus pi over 3. So once again, kind of a big picture observation. Whenever we're using a substitution, here specifically a trig substitution, to evaluate a definite integral, we do have to change our corresponding limits of integration. The upside to this is that once we have changed and we have this equivalent trigonometric integral, we just need to evaluate it. We no longer need to put anything back in terms of the variable x.